everyone, my name is Eva and I'm an engineer on the Google Web team. This talk is about Caching API and Service Worker, two technologies that are part of the foundation the progressive web apps are built on. I believe that caching in Service Worker, when done in the right way, can offer a tremendous advantage both to the performance and reliability of your web apps and websites. Today, I want to share with you the process I follow for designing successful service worker flows. In particular, I want to share with you what questions I consider to be important to ask yourself when you're adding caching behavior to your app. So, in the good old times, before the progressive web apps were a thing, our options were rather limited. User could be in two states. Either they were online and then, they could access the internet, or they were offline, and in such case, even opening the web browser was pretty much useless. Well, actually, there were three states. There's also something we call Li-Fi, which is when your device thinks it's connected to the network, but actually it isn't, or the network is not working great, and you're in this weird state where you're connected, but not really. It's like a Schrödinger cat of connectivity. You don't really know what state you're in. So in those times, everything really depended on the network on your website. If you were connected, you got a beautiful website, right? If you were not connected, you get a downosaur or whatever the browser decided is worthwhile to show you when you didn't have an internet connection. And when you were on Li-Fi, usually what you get is a mess. Part of the website could load, but not everything, and it's really confusing for the user. Here is an example. This is a very small, tiny e-commerce app that I helped to write recently. And if you're online and the caching is not implemented, it works beautifully, right? And then if you're on Li-Fi, which means the network is patchy and the connection is not great, it might happen that parts of the website are loaded, for example, the shell of the application, but the images are not loading and they make your site look broken. It can go even worse. When the styles are not loading, the site is pretty much unreadable, unusable, and the user experience is really, really bad. This is really a big problem because this is a more dangerous situation to be in than the full offline scenario. Why? Because when you're offline and the user sees downosaur, they think, okay, well, the network is not good. But when they see something like this, they think your site is not good. Your site is broken. They're more likely to blame your site than actually the connectivity. So usually, they exit the site, and you don't have a guarantee that they will ever come back. Fortunately, Caching API and Service Worker can help you mitigate this risk of losing users before of the patchy and not ideal network connection. My colleague, Jake, made this website some time ago. Is Service Worker ready? And he was updating it with the stats of how browsers support Service Worker. He was super, super happy this year to switch it to a single yes on the website. So Service Worker is present in all modern browsers these times, and this allows you to consider it as a core part of your site's architecture rather than just a progressive enhancement. So what is Service Worker? Service Worker is a little script, or not so little, depending how you write it, because you write it. It's a script that you can install on your website, and it serves as a proxy. Pretty much it allows you to control how your website is using network resources. So, for example, if the connectivity is not there because you're offline, or it's just patchy and not ideal or slow, it can decide to take resources from some other place. For example, cache, but not only. It can pretty much decide what to do, and because it's scriptable, it gives you a really powerful tool to manage where the resources come from to your web page. So, given that we can, use it in all other browsers, let's cache. Maybe we should cache everything. They just take the, all website and push it to this poor user's tiny phone device and be done with it. It's actually very tempting because it's super easy to do these days. A lot of frameworks and app generators offer you helpers to enable caching out of the box. For example, if you would be using Workbox libraries, this is a set of helper libraries for service worker, and you were using Webpack, pretty much this is all the code you would need to take all your app and push it to the user's cache, right? So it's very tempting because it can be very easy. Well, I do not recommend that, so don't quote me on that code, please. Why I'm not recommending that? Well, you saw this slide. I think Sam showed it to you in the morning today. Size is one of the core advantages of progressive web apps. We're able to make the progressive web app really small by being selective about the resources we're pushing to the user, by prioritizing them and by structuring them in a way that their value ratio to the storage ratio is really high. That's why I would recommend you to have a plan, and proper design for how you want to approach it. One of the biggest challenges we face here is that as opposed to native apps, we have URLs, and our websites and web apps are usually composed of many URLs, or in a single page app, many views, right? That's an equivalent. So if you want to know how big is your app that you're going to kind of install on user's phone, it's not enough to check a single URL, right? Usually it's a bunch of URLs or views that you need to take into account. So for example, if you go to the network tab and you just check how many, kilobytes or megabytes you need to download for a particular page, that's not really your app size, because your app size is counted for multiple URLs or views. So how to actually see the size of the app you're trying to cache on user's device? Well, in case of this app, we can open Chrome DevTools. Yes, and this is the view where you can see the nice chart that shows you the storage of your app. How to get to that view? Well, in the Chrome DevTools, you need to go to Application and then go to Clear Storage. I know it's not ideal because you don't want to clear really anything, but don't be worried, just click on it and it will show you the data you actually need, right? And then you can see the size, all the URLs from that particular origin, how much space they're taking in the cache at the moment. And the moment is actually important because, websites with enabled caching go through kind of a life cycle. So here I just opened this website and nothing really happened yet. Just IndexedDB was initialized, so it takes only 270 bytes. But just a moment later, when Service Worker is installed, it already takes some space in the storage. And then when all the resources that I told Service Worker to cache for that particular homepage are cached, it takes 150 kilobytes. So it's different than in native apps. You don't have like a package that you can wait and then okay, that's how big it is. It actually changes over time, and you should learn how to control it in your everyday developer workflow. What is more, this page, this particular URL, if I go to homepage, will work fully offline because it's cached, right? But if I navigate to any other view in my app, it's not. I need to cache all other URLs in order for this to be fully offline compatible. And then the size of my app just grew to 1.4 megabytes, right? So it's very easy to kind of cheat on the size of your app or not be accurate because you're just calculating some URLs or just the homepage, while actually the storage that accumulates over time is much bigger. So just be mindful of user resources, learn how to control the weight of your app, and get into a habit of checking it regularly if you work with caching in Service Worker. Well, hope is not a strategy, so it's much better to think through all of that ahead of time. So my first tip for you is just have a plan. Don't jump straight in, enable caching of everything, and hope for the best. It might just backfire, and the users will delete your app from the, for example, home screen, right? So have a plan. Okay, so let's talk about creating this plan. Let's talk about designing the service worker flow. Service worker sits in the middle between the web page and the network. So there are two parts of the strategy. One is how it talks to the web page, and the other part is how it talks to the network. The one that talks to the network is the caching part, and the one how it talks to the web page is the serving part. And those keywords are kind of arbitrary. That's how I call them, but you're free to call them any other name that you want. So let's start with the caching part. What do you want to think about when designing caching for your app? Well, usually you want to know what to cache, when to cache, and when to update in case something changed. I also add one very important, in my opinion, question at the beginning, which is what not to cache, which is even more important than what to cache in some cases. So what not to cache? Well, sometimes our web pages are not ideal in terms of performance. They have assets that don't really need to be there. Maybe there are unoptimized images. Maybe there are some other issues. So it's really important to make sure that you cut the fat and make your site as lean as possible before enabling caching. Because it's one thing to use a lot of heavy resources on the network, and entirely different thing to actually push it to user device, store them for arbitrary amount of time, and maybe overpower the user's device. So first thing, cut the fat. As I said, you need to make sure you're serving the right images, that you don't ship unnecessary code, that you don't ship unnecessary fonts. There's a lot of things you can, like easy fixes that you can do on your website to make it leaner. And in the link displayed on the screen, you can find many more tips of how to actually prepare your website before you go for any of the caching strategies. So now we removed all the stuff we're sure we don't want to cache. We need to think about all this other content that brings value and that we do most probably want to keep in the cache. So I'll give you an example what I mean by having a content strategy. This is a Women Tech Makers website. I worked on it in the previous year, and it's a very rich visual experience. There's a lot of imagery there. I was working on caching for that site, and if I wanted to push all of that images into the cache, it would be huge. It would be just enormously big storage space, so I didn't want to do that. So I started to look, well, if I disable all the images, what would happen? Well, the site is unusable. So obviously, going for no images is not an option. Going for all images is not an option. How do I actually find this middle ground between the two? Well, I decided to think about images by the function they fulfill on my page. For example, those images highlighted here in yellow are images for navigation and action. They're super important. If they're not there, the user cannot navigate to parts of my website, they cannot sign in or something like this. So they need to always be there. There's no discussion. Now, the ones highlighted in red are responsible for branding and priority. So they're not as crucial as the navigational ones, but they're pretty important for my business. Not so much for my code, but for my business. So I give them a priority. Now, the ones highlighted in blue are decorative. They bring the good user experience, and then they make the site looks nice. But if they're sometimes missing, it's not the end of the world. Like, the site is still usable. It can provide schedule for events and other information. So I call them decorative. And now the last type of images is informative, which means they don't only look nice on the website, but they actually convey some information. In this case, it's logos of the projects, right? So they convey some information. Now, depending on the function, you can change the behavior, how those assets behave when requested while on poor connectivity or when offline. For example, yellow ones need to always be there, and they're small because they're icons. So I can just embed them in my document and never think about caching them because they're always there. If the document is there, they're part of the document, they're always present. I'm done, right? Now the red ones, I said they have priority, so I always put them in the cache. I pre-cache them. The blue ones, I cache at best effort, which means I cache some of them, as many as reasonably possible, but with some limit. Like, for example, the last accessed 50 images, or up to some cache size, right? So it's cached with the best effort. And now the green ones are not cached at all, but I provide a meaningful fallback. In this case, I just say, oh, this image is not there, so you get like an offline icon, but you do get the name of the project. So the information is still conveyed. And I can do that because all the things I do in service work are written in JavaScript, so I can really do a lot of, put a lot of logic in there, right? So this is an example, how would you divide your content and be selective about behaviors you associate with each of the resource. So that's the tip number 3. Be selective, be mindful about what is important in your site, what is critical, what is less critical, and then adapt your caching strategies to that knowledge. That was the part about like what to cache. Now, the second question we need to consider is when to cache. There are 3 types that we can consider, most usual ones: pre-caching, runtime caching, and the on-demand caching, which is actually kind of similar to runtime caching, so I focus mostly on the first 2. In order to talk about the right timing moment on when to put stuff in the cache, I need to talk a little bit about service worker lifecycle. This is a very simplified version of the lifecycle, but it should be enough for our needs. So first, when the service worker is requested by the page and installed, well, there's the install event, right? Once it's installed and does all the work that we required during the installation step, it activates, which means it takes control of all the tabs of that particular site we have opened in the browser. And once it's activated, it can actually respond to stuff that those tabs are doing. For example, it can respond to fetch events issued by the site or to messages sent by the site, right? So there is install, activate, and run step. And usually caching can happen in the install step or in the run step. In install step, that's the pre-caching, where we push to cache ahead of time resources that we're going to use. And in the run, it's runtime caching. On-demand caching is a type of runtime caching where the request to cache something comes directly from the user. For example, imagine you have an article and the user has a button saying like, save this for later, right? So the user can explicitly request, now is the time I want to cache it. So what are the differences between these options? Well, pre-caching pushes assets to cache ahead of time, which means you arbitrarily decide what goes into cache and what does not, right? So for example, my priority images were pre-cached because I know they're going to be important and they're on almost every page and so on. So yeah, I arbitrarily decide as a developer, they're important, I want to pre-cache them. Pre-caching is very good for static assets, like for example, styles or scripts, or as I said, important messages. Once you push them to the cache though, it's important to remember that at some point they might change, right? Your style might update, or the script might get new content. So versioning is really important. If you don't version your files, it will be hard for service worker to add logic to it so that you can distinguish when the file updates and when the version stored in the cache should be refreshed. Usually those resources update when the service worker updates, because it happens in this installation step, right? So it's not enough to bump the version of your assets. You also need to bump the version of the service worker. And here's the example, right? You have the install step. You have some resources you push to cache in that step with the versioning hash attached to it. And usually the most convenient thing is to just hash based on the actual content of the file. Then you know that if the content did not change, the hash did not change, so you don't need to refresh the content. And also you need to change the service worker version, or just change its content in some way so that browser knows, aha, this is a new service worker with new assets. I need to refresh everything. So use content versioning to avoid the situation where the user is stuck with the old versions of your assets forever. And there is no way, because they always come from the service worker, there's no way to really update them without changing the version. Pros and cons are as follows. Like, it's really easy and automatable because today we have a lot of tools that allow us to do this versioning for us, and that actually can generate the whole precaching logic. Workbox is one of the examples. And it's very good for the performance because you push those files usually before they're even requested by the page. So once the page tries to request them, they're already there, right? You skip all this network time. It's not good for some reasons as well. It's not for a whole site. As I said, like, because of the size of the app, for big apps, you don't want to push every single asset and URL into your precache. It does cause some upfront network congestion, right? So when you open your site and you immediately tell service worker, please fetch everything in the world and put it in my cache, well, that will slow down other requests that the site might be using. There is a possibility you'll be caching URLs that won't be accessed by the user eventually. So you need to be arbitrary, but also mindful about what you put in there. And it's hard to update unrevisioned assets, as I said before. So now runtime caching. Runtime caching happens after the installation, during the normal life cycle of the web page, right? So you cache resources usually either when they are accessed for the first time or when the user, through user action, requests those resources from the server. It's very good for dynamic content. For example, if you have a blog, right, and you have like title embedded in the URL, you don't want to put a versioning hash there, right? So it's much easier to use the runtime caching with that, because anytime this resource is accessed, it can be also put in cache, which means you can update it not only when the service worker is installed, but actually during the normal usage of your app as well. Updates depending on your strategy, so you can update it depending on your development workflow. And it's very good for like non-crucial content, which means it might happen that the runtime event didn't happen. For example, the user didn't access that particular URL, so you should never assume for sure it's going to be in the cache, right? It might happen that it's not there, so you need to think about having some backup plan. This is the example, right? Here I react to a fetch event, and that's the moment where I go to the network, fetch the resource. I usually send it back to the page, but I also save it in the cache for the next use. As I said, the updates are independent from the server, from the updates of the service worker, and you can cache files depending on the user behavior. But the assets need to be fetched first, so it's a bit less performant, immediate than the precaching. And the most important thing is the storage size grows over time, right? Because during runtime, you just keep adding stuff to your cache. So you need to think about how much stuff you put there and have some limit either on number of entries or some expiration policy to not overrun your cache storage. Here's an example, right? This is the e-commerce site I worked on. If I just cache the home page, it's 150 kilobytes. If I add one more URL with accessories, it grows to 300. If I go to another category, it's 800 something. And then if I have full site cached, it's 1.4, right? So it's a growing size of the app over time, which is very different from native apps. And mind that this is a very tiny app, right? For something super big like Amazon, this size would be much, much bigger. So you really need to think about how to expire and remove stuff from the cache that is not crucial. So that's the tip number 5, control the size and learn how to handle it. Now, the serving part, the second part of the strategy, right? We had from the caching. When service worker is sending the resources back to the page, it can do it from multiple sources. It can do it from network, as if it would happen without the service worker interruption. It can choose to take it from cache, but also it can implement some custom logic to create the response. For example, it can use some of the standard JavaScript template engines to create the response. So there is actually a lot of possibilities. Here are some of the strategies that are implemented in Workbox, which is a set of libraries that help you implement service worker caching logic. And they're very typical. I'm not saying you need to use Workbox in order to take advantage of them, but it's really useful even to go to Workbox source code and just see how those caching strategies are implemented over there. Let's look into it in a little bit more detail. So this is the time that it takes for the service worker to respond to the request from the page. The yellow bars are when the asset is accessed from the cache, and the blue one is the time it spends on the network. If service worker takes asset only from the cache, it's cache-only strategy, well, it's really quick response time, right? The problem is, if the resource is not there, it replies with nothing, right? So you need to use this strategy only when you're pretty sure your stuff is going to be in the cache. Cache first means it first looks in the cache for the resource. If it's not there, it goes to the network. And the O points are put in the place where I think is the most optimistic scenario, right? So in cache only, like the end of the whole process is also the most optimistic. In the cache first, the optimistic version is it was in the cache, so we finish after a few milliseconds, but in the more pessimistic scenario, it finishes where the blue bar finishes. So it takes significantly more time than cache only. Network only, this is where service worker is kind of transparent. It goes always to network, right? So look at this. It actually takes, in theory, less time than, to go first to cache and only then to network. So sometimes you might want to choose that strategy. In network first, again, you first go to network, and if the network is patchy or if the network is down or you're offline, you get it from cache. This is a better solution for the resources that you want usually to be fresh and treat the cached version only as a backup. Stale while revalidate strategy is interesting because you kind of do both. Like first you serve the stale content, which means the one that is stored in the cache, but at the same time you go to the network and check for the newer resources. The difference between this and network first is that, well, the network response will be only used next time this resource is accessed. So first, the user will always get the old one, but on the next time, the new version might be stored already. And then, of course, even in Workbox, it's possible to write your own handler, combine different strategies into whatever flow you find reasonable for your users. Here's an example for the custom handler that was used on this page to create custom images. Here, I'm using a Workbox strategy cache first, which means on the fetch event, I am to this particular route on Cloudinary. I try to answer with the cache first strategy, but if it fails, I actually serve a fallback image. So this strategy says, go to cache first, if not go to network, if both failed, serve the fallback image, right? So there's a lot of mix and match possibilities. Let's see how it plays out in practice in our previous example, right? We had 4 types of images on that page. How this would translate to my caching strategies from Workbox that I showed you before. Well, these ones are inlined, so we solved it just by inlining, no caching involved. These are the important branding and priority strategies, which means I'm pre-caching them. And you can see like both parts of our strategy are implemented here as pre-cache and route, which means I register this route, I push it to the cache ahead of time, and after that, it's always being served from the cache. I don't really need to care about updating it, because you can see that the image is versioned, which means there's very, very little chance that the content of the image will change without changing that little number attached to the name of the file, right? So it's super safe to serve it always from cache. Now, selective images, I cache at runtime. When user navigates the page and looks around, there's high chance that they will keep coming back to the same locations. For example, I don't know, for the website of this conference, I keep coming back to the schedule or to the list of speakers. So it's good to cache those resources at runtime. The important part here is I don't only cache everything on runtime, but I set the max entries and the max age seconds, which means that I don't overrun the cache. This also means that sometimes those images will not be in the cache, and they might be missing if they're not in the network as well. But this is okay. Like, I apply this strategy to the images where I can afford for them not to be found in the cache, and I can fall back to, I don't know, CSS color, or just allow them to not be there. And informative strategies, that's the custom handler I showed you before, with the difference that here I actually also use some metadata I get in the fetch event to add information, in this case the name of the project, to the response. So you need to find your balance between the how much storage you want to take on the page and how fast you want to serve everything, right? One thing that can also play a role is the type of network you expect your users to be in. If you launch a website that is used in a place where internet is very well developed and the network speed is very fast, and you expect it to be accessed mostly on desktop, then probably you can have use less storage but use more network connection. And on the other hand, if it's a more restricted network, you might consider caching more aggressively. So to sum up, caching is primarily about resiliency and only secondarily about offline. By applying the right caching strategies, you actually can help users by providing faster response times to the requests on the page, on flaky connection, and on patchy network. So actually, it's more important even to fix this Wi-Fi situation where the network is just not reliable enough to make your app work independent of the quality of the network connection. And to go fully offline, that's a secondary goal, only if you think your business model actually requires that. So first of all, don't jump straight in and cache everything. Just have a plan, think it through first. Put it on paper, preferably. Secondly, cut the fat. Fix your site before you go for caching. Fix usual performance problems, because they will double your problems when you try to cache everything. Be selective about your content. Understand your content priorities and your content value. Use content versioning to not lock yourself in, or rather, don't lock your user in an old version of your app. Control the size of your app using developer tools or other tools available on the market. And balance the speed versus freshness versus reliability of your site. I hope this helps. I hope this gives you some overview of at least some of the questions and problems you need to consider when trying to develop and design the proper service worker flow. Thank you so much. This is the link to the slides. And if you have any questions, feel free to meet me after the presentation. Thank you.